Hi there, Mr. Sutton here, bringing you the IM3 Chapter 6 Quiz 1 Extra Practice Solutions on simplifying and multiplying rational expressions. To simplify this rational expression, I need to first make sure there's no common factors, and to do that, I'm going to factor out my denominator so I can see what I'm dealing with down there. So it looks like I can take out a 16 from both of those, and also an x, because they each have an x, so 16x. So that makes 32x squared into 2x, and then negative 16x, that's going to become a minus 1. So these x's outside the parentheses can definitely cancel. And then 36 and 16, I can reduce those. Those are both divisible by 4. So 36 becomes 9, and then 16 becomes 4. And again, those x's got canceled. So we've got a 9 over 4 parentheses 2x minus 1. Before we can fully simplify this rational expression, we need to do as much factoring as possible. So for the numerator, let me just split this up into a fraction here. For the numerator, first I look to see if I can take out any common factors. Well, 24 and 30, those are both divisible by 6. So I can take a 6 out. And these terms each have an x as well. So 6x can come out of there. And now what's left over? 24x squared divided by 6x, that's going to be 4x. And then negative 30x divided by 6x gives me negative 5. Down below now, it looks like I can also take a common factor out of these two terms. These are both divisible by 8, so I can take an 8 and also an x out of there as well. So that gives me x instead of 8x squared inside there. And then negative 16x, that's going to become negative 2. For my next step, now that I've done as much factoring as possible, let me see if I can reduce or cancel some things. So the 6 and the 8, those can be reduced by 2's, so I'm going to have a 3 and a 4 for those. And then these x's can actually cancel out completely. I can't cancel anything else out because there's nothing that can be separated out by multiplication. So let me just go ahead and clean up what I've got here. In the numerator, I have 3 parentheses 4x minus 5, and in the denominator, 4 parentheses x minus 2. To simplify this expression, let me make sure there's no common factors, and let me start that by actually factoring to see what the factors are. So in the numerator now, I need factors of negative 45 that add up to negative 4. So we got 1 and 45 doesn't work, 3 and 15 is no good. 5 and 9 would work if I had positive 5 and negative 9. So x plus 5, x minus 9. All right, 1 down, 1 to go. Let's do the denominator. We need factors of 54 that add up to negative 15. So 1 and 54 doesn't work. 2 and 27 doesn't work. 3 and 18. 3 and 18, well, that would work if one was negative and one was positive, but they both have to be positive because it multiplies to a positive. Or they actually have to both be negative. Multiplies to a positive, adds up to a negative. So let's keep going. How about 6 and 9? Well, yeah, negative 6 and negative 9 adds up to negative 15. So we have x minus 6, x minus 9. And now these common factors of x minus 9 will cancel. So that leaves us with x plus 5 over x minus 6. On this problem, in order to simplify this, we eventually need to get a single fraction instead of 2, and we need to be fully reduced. So it's up to you whether you reduce before multiplying or after. I usually try to do it before, just because that gives me less to multiply. So taking a look here, it looks like my 10 and my 16 can be reduced. It's fine if they're in different fractions as long as we're multiplying the two fractions. So 10 and 16, that reduces by 2's to give me a 5 and an 8. Next, these x's can also be reduced. So if I cross off 4 x's on both sides, that leaves me with 3 x's downstairs. 7 minus 4 gives me x to the third in the denominator. And up here, this is just an invisible 1 that I don't have to write anymore. So multiplying now straight across on what I've got, for my numerator, all that's left is a 1 and a 5, so 5. And in the denominator, I have an 8x cubed. To simplify this expression, since I'm multiplying, let me actually factor and cancel out whatever I can and then multiply. So in the upper left here, I can take out an x, leaving me with an x plus 5. And in the lower right, I can take out a 7, That's x plus 5 left over from that. I can cross-cancel these x plus 5s because I'm multiplying the fractions, so cross-canceling is allowed in that one situation. And then 9 and 24, those can reduce by 3. So 24 is now an 8. This 9 down here is now a 3. Multiplying the leftovers, we have x times 8, which is 8x. And 3 times 7 in the denominator gives me 21. To divide these rational expressions, let me turn this into multiplication by multiplying by the reciprocal. So same, change, flip. Keep the first fraction the same. Change this to multiplication. Flip the second fraction so that this 9x minus 36 is now the denominator of that fraction. And just like any multiplication problem here, let me go ahead and factor and cancel whatever I can before I even think about multiplying. In the upper left, then, we can take out an x, leaving me with an x minus 4. In the lower right, I need or lower left, I actually need factors of 14 that add up to 9. 1 and 14 doesn't work, but 2 and 7 does. So x plus 2 and x plus 7. In the upper right, we need factors of negative 35 that add up to 2. 1 and 35 is no good. 5 and 7 works if you have negative 5 and positive 7. So x minus 5 and x plus 7. And in the lower right, looks like I can factor out a 9, leaving me with an x minus 4. What cancels here? Well, it looks like these x minus 4s can cross-cancel because I'm now multiplying. So multiplying allows you to cross-cancel. Because if you did multiply right now, they would just end up in the same fraction anyway. These x plus 7s across from each other can also cancel. And it looks like that's it. So in the numerator, I have an x times x minus 5. In the denominator, I have this 9 and an x plus 2. And that's as good as it gets.